Thank you. I'm going to talk to you today about a new decision support system that is being built as part of the Port Phillip Bay Coastal Hazard Assessment Project. The hazard assessment will define the extent of land expected to be threatened by the coastal processes of inundation, erosion, and changes in groundwater under different climate change scenarios. A high-resolution hazard and related datasets generated as part of the project will be displayed in the new marine and coastal decision support system, which will enable users to evaluate and interpret hazard impacts on natural, cultural, and economic assets now and into the future. It's the first system that integrates multiple hazards and infrastructure for adaptation and provides uncertainties relating to models and projections. The decision support system is being developed by CSIRO Data 61 in partnership with DELWP, with input from a user testing group made up of coastal managers around the Bay, such as councils, the EPA and Melbourne Water. So the Marine and Coastal Decision Support System is a repository of coastal hazard and related data. It's a geospatial visualisation tool and a hazards analytics tool. It allows users to look at any section of the coast and see what the impact of coastal hazard will be for different climate change scenarios. Users will be able to perform various calculations such as location-based hazard estimation and distance and area calculations, which means users can evaluate, understand and interpret the impacts of coastal hazards on lands and assets under different climate change scenarios. It is being built on an open source web-based geospatial platform called Terra.js. It's a digital twin of the environment. All IP and data sets are owned by the state and Commonwealth governments. There are a range of data sets in there, obviously the coastal hazards, but overtopping hazard, coastal structures, beach profiles, coastline classification, and aerial imagery dating back from the 1930s. But it has the capacity to incorporate thousands of data sets. It's a dynamic live system that can be updated with new data or policy, for example, the sea level rise benchmarks. In terms of applications, in the coastal and marine planning and management world, land use planning, strategic projects, environment, geology and geomorphological studies, infrastructure planning and management, emergency management, and compliance with Victorian marine and coastal policy. The DSS can really be used for a range of purposes and has therefore a wide audience. So what does it look like? Here you can see Point Lonsdale, aerial imagery on the right from the 1960s and on the left from 2010. So you can use a sliding bar to see how it's changed. For example, you could look at the beach width, look at the vegetation along the shoreline, or you could look at any infrastructure on the coast. Zooming in now to show inundation at a maximum water level. So here in Port Arlington, you can see on the coast, and this is under a 1.4 sea level rise scenario using sample data. Here again at Port Arlington, this is showing inundation of the current coastline on the left and on the right for a 1.4 metre sea level rise scenario. Again, you can see that the blue here showing that whole bit of land is inundated. Now, in terms of erosion, what you can see here is that there's three zones. The zones represent different probabilities of the coast being impacted by erosion. So the red zone is 95% chance of being impacted, the orange is 50%, and the yellow is 5%. Here to the other side of the bay, down at Point Nepean, here you can see the distance to the water table for groundwater. And you can see there's three different depths: shallow, intermediate and deep. In the same area, you can also see the water table salinity. So how saline is the water table at different places on the coast. So as you can see, what you can use the DSS for is to zoom into an area of interest and select a particular sea level rise scenario and identify what the impact of coastal hazards will be on that piece of land, the infrastructure that's there. It's a brilliant tool. You could just zoom in, see what the impact is going to be, and then make decisions based on it. Now for a bit of a demonstration. So this demonstration will show two different analytics tools. Initially here you can see this is where the data is uploaded, and you can find the tools there as well. So we're going to look at maximum flood inundation first. So that's now been turned on, and you can zoom into a particular area. There you can see the inundation with the different colours showing depth. Going in to turn on the actual tool. Initially, it's required to draw a line, so from the coast, running inland. And now to actually run the analysis. You can see that this analysis is for a 1% storm surge and no rainfall. And you can see here the chart's been developed. So on the x-axis is the distance along that line, and the y is the depth. And the different colours represent the different sea level rise scenarios. And this can also be downloaded and then inserted into any other system. And now for the second tool, first getting rid of the line that we drew and removing some data there on the left. So this second tool will be looking at the area inundated in square kilometres within a selected polygon, along with the different sea level rise scenarios. So first you need to draw your area using the tool. And then you run the analysis, again a 1% storm surge and no rainfall. And then you get your chart. In this case, as you move along, you can see the different sea level rise scenarios, and the three colours represent the different flood extents, the probabilities. Again, that can be downloaded. Okay. So, future development. The tool is still in development and we're still working on it. As you can see, there's a wide variety of coastal planners, asset managers, community, wide audience that could use this. And I'll take this opportunity to mention that the system will be secure and have unique access levels. As you can imagine that the data is sensitive and may cause alarm. Approval will be sought from the Minister before release of the datasets. And so far, the demonstrations that we've held for our stakeholders have all received positive reviews. Lots of excitement in ways that people can use this for their work. It can be used to make decisions on how you manage the coast. And for example, it could be used by the CMAs for their coastal erosion advice. In terms of capabilities and innovation, the plan is to integrate the Victorian local coastal hazards and climate data that's already available, but you can add any statewide data sets, catchments, rivers, etc. Adaptation modules coupled to hydrodynamic model and coastal erosion protection models, so you can make changes as you're going. And obviously drone data sets as well. So it's pretty exciting. I'm excited and we're looking forward to investing in this further. And if you would like to find out more about the project, there's a link there. If you'd like to speak to me directly about the decision support system, please contact me on the email. Thank you very much.